Awesome. All right. Thank you, everyone, for joining us on this. I don't know what day it is. Wednesday. It is a Wednesday. Yeah. Thank you for joining us on this Wednesday. We got another stream of mission briefing coming in hot. I have with me Kyle Schrade. Did I get that correct?
Close enough. Yeah, pretty
Uh,
much.
2 seconds ago, he told me, and I already messed it up. I'll let him introduce himself in a minute anyway and correct me on my mispronunciation of your name. I do apologize. But yeah, for those of you that don't know me, I'm Kurt Kemple, developer advocate with Apollo GraphQL. Mission Briefing is a fun show where we like to get folks on from the community, from Apollo, from just about anywhere to kind of talk about anything awesome going on with GraphQL at kind of the tactical level. Yeah. So again, I've got Kyle with me. Kyle, you want to go ahead and take a second, introduce yourself, maybe introduce folks to StockX and what we'll be chatting about?
Yeah, for sure. So my name's Kyle Schrade, as Kirk already mentioned. Um, I am a developer at StockX. I primarily work on our Edge team, kind of helping stuff go back and forth, making sure it's efficient and all that, and kind of led the adoption of GraphQL for a while. Then it's been taken over by my team, and we've done a pretty awesome job. Um, StockX is where I work currently. They are a let me get the PR approved wording here so I don't misstep within the first like 2 minutes. Uh, the world's first stock market of things, powerful platform connecting buyers and sellers around the world for high demand goods, and it's dynamic pricing, real time. Think bid and ask just like a stock market. That's where the stock and StockX comes from. We have a ton of different items, and anything from Nike to Supreme to Bape to Gucci to Rolex, all of that stuff is on there. It's pretty awesome. It's if you go look at it, it is a crazy thing to see how much just products there are. We have over 108,000 products currently listed, and
Wow.
a ton of stuff. Yeah, man, there's a ton. Like there's stuff I didn't even know about on there, and all of a sudden, in the deep depths of browsing and testing things, you find things and just like some
Yeah,
pretty
that
cool stuff.
must be cool. That's pretty wild to like explore your own kind of website and discover new things. I love stuff like that. That's very cool.
Oh yeah,
Yeah, it's
you gotta
funny
have
'cause
your favorites though.
yeah, yeah. I was actually going to ask you like what kind of things are on there, but you really just answered my question there. It's funny because I told a couple of my friends that you would be coming on, and they were like, "Oh no way, StockX!" Like I use that all the time. Like I got a couple sneaker file friends, so they're all about
Yeah.
StockX. Yeah, and it's interesting. So you all are using GraphQL, and how did that journey kind of begin, right? So you said you kind of led that initiative. What was that like, and how long ago was that?
So we did it about July of last year was when we started it. And what ended up happening is we had a product where we had to make a bunch of changes to how kind of some of our data comes up. In an old RESTful world, we were kind of in the middle of breaking apart a monolith, and we had that edge layer where you have lambdas that take some responses from the back end, change them a little bit, and then kind of give them back to clients. And what we realized is like, hey, we're doing the same logic in like 7 different places, and this is like the 3rd or 4th time we've done it, and now we're just starting to layer this, like there was change A for this project, and there was change B for this project, and we kept layering these things in like 17 different files across the board. Like you would change one endpoint, then you'd have to go change another endpoint, then you have to go change another, and like we ended up having some problems doing that when we did it because there was just so many changes. So we started to jump to GraphQL of like, hey, maybe this can solve it. We have a lot of relational type data, and if we update one node in our graph, everywhere gets that update. We don't have to consistently change a bunch of different places. You define your thing in one spot, you change that thing, everybody gets your update. And it was like, oh, that's great, and with backwards compatibility, like it was great too of like, hey man, we don't have to force people to update their apps. We don't have to force all these breaking changes on people, or like we might be going through the app and it might crash because you expected data at one time. Now we made an update to not get data. Like, hey, it's backwards compatibility is awesome for that.
Yeah, and I feel like this is a theme that you hear constantly, which is like, in the REST world, when things change, like updates have to happen in lots of places because there's no contract, there's no security between like how it's accessed and how it's used on the client. It's often left up to the clients to know. Real quick, as a side note, is the web app the only app? Do y'all have like a mobile app or anything else like that? And is that powered by GraphQL if you do have it?
Yeah, so we have a web app like you mentioned. We also have an iOS and Android app on the App Store as well.
Okay.
They're all powered by GraphQL.
Okay.
We're kind of in the transition of moving as much as we can. Our internal goal is, more than it is now, but we're getting there. We're slowly getting there to more and more stuff. Eventually, hopefully, we can get most of our stuff to GraphQL, but we're still in that transition phase for now.
Okay. Yeah, awesome. That's cool. So incremental adoption kind of process in the middle of that sounds like. Again, pretty standard story. So this is cool. So what was your experience like when you first started migrating to GraphQL? Was it easy to get the buy-in? Was it a struggle? How did you also go about like making the transition?
Yeah, so we took a big project, or not a big project, but a project that would have been really costly in the back end of basically stitching together a lot of shipment information. So we're redoing how our shipments worked.
Okay.
And what that does is like it just needed a bunch of data from a bunch of other places, and it just wouldn't work out nicely if we didn't do a nice, like have some stitching logic, some caching, kind of all the benefits you can get of having that single entry point in GraphQL and
Yeah.
having your GraphQL server solve it all. And we did a little bit A/B testing before we put it out, and it was something like, without GraphQL, the request would time out. Like we couldn't get one to work. With GraphQL, we were getting like, it just with no real time on it, we were getting like 2 or 3 second response times, which still isn't great, but is way better than it timing out. Like it worked, but it worked slow. We ended up getting it down, and that was kind of like our first use case of like, hey, this can really help out. And after that, we actually moved towards doing our home screen. Our home screen is our biggest win so far.
Wow.
We saw second increases overseas. And normally as a developer, you don't get to talk in seconds. Like we were literally seeing over 1 second, and we were counting stuff in seconds of increases, which was pretty crazy to see.
Wow. Yeah, that's very interesting. So I guess, well, we got a question about Federation, but I feel like we'll get there. We'll definitely get to that, Tatra. Thank you for dropping that question in the chat. But yeah, so, okay, so what was the migration like, though, let's say at the code level, like in the front end? So here you are. You decide homepage is the target. We're going to do this. What did that migration look like?
So I can't speak a ton to it. I did more of the server side stuff, and we had
Okay.
different people, different teams do the front end stuff.
Yeah.
But a lot of what it was is we combed over kind of what our response is today and what are those pieces that you really need, and did more of like just-in-time type schema. So instead
Okay.
of going and getting everything we possibly could and shoving it all in there and hoping it all works,
Yeah.
we took kind of like the pieces you need. And we ended up taking more than we needed, but we took all that stuff, we shoved it in, put some caching and stuff, data loader, all of that fun jazz behind it. And we, kind of said, here's the schema, does this work? And we had a few iterations on that, and then we put that out, just after Black Friday last year, and it's been on ever since, which has been pretty awesome.
Cool. So kind of like a feature by feature migration, just looking at the data needs for a given particular feature, make sure that's represented in the schema, and then just incrementally keep moving from there. Does that sound about right?
Yeah. The only thing that really is a little different than that approach is we took a bigger step at the start. So instead of kind of taking that increment at the start, we just said, hey, we're going to cut off a big chunk and
Oh,
kind of
okay,
work.
got you. Gotcha.
And it's worked out well in some places,
Yeah.
and there's other places we look back today like, man, what were we doing with that?
That's interesting. So I guess that's actually going to bring me to my next question. So here it is. You kind of took off this bigger chunk, and you realized that like, oh, maybe the schema actually doesn't represent the needs of the client as much as we would like it to. What was it like? Is that still there, or like what was it like to kind of fix that? Like, did you deprecate things, move things? What was that process like?
So fortunately or unfortunately, we haven't actually had a problem where we've had to like remove stuff from our schema. It's all been kind of either used or in a spot where it's like, it can stay for now. It's not hurting anything. It's just nobody's pulling that field right now. The big problem we had, and here's actually to the question in chat, is we actually we had a great idea at the start, or at least we thought it was, of creating this pure federation. It's purely going to make API requests. It's going to pull that back and immediately return it and not do any type of transformation or any logic like that.
Okay.
And
Like
we
a
realized that was
pass
more
through
like,
kind of. Yeah.
yeah, with no mutations, basically take API, return it back, and allow like
Gotcha.
to plug their stuff in, right? So like, hey, as an iOS engineer, I want to take this part of a product and change it a little bit to be iOS specific. And we kind of thought, hey, we'd have our pure federations where we're making pure calls and pure returns with no, mutations, nothing to dirty that water.
Like just queries, essentially.
Just straight up pass-throughs, back and forth, no changing of data. And we quickly realized after like a few push notifications and our services tanking, like not a good idea. One request hangs, two requests hang, and then all of a sudden the server starts really struggling, and we go from there. So we've actually been working to destroy that recently and break apart that federation. And that was actually the question in chat: is how do we break that down with no runtime problems?
Right.
So we actually go ahead.
Oh, that's what I was just saying. I'd love to hear that. How did you handle that?
Yeah, so shout out to Aaron on my team. He actually came up with the idea, and it's a really scary idea. It works really well. It is the scariest thing you'll do. What ends up happening is we do what we call the Federation Shuffle. We take all of our end state of our schema, and we upload that to Apollo. And we're using managed federations, and that's kind of the only way you can get away with this. And we take that end state, we put it in Apollo, and we shift everything to that end state. So we kind of fake out our entire gateway and all of our services and say, hey, this is what the schema looks like, even though the code under it still has all of the old stuff. So if you're shuffling like a product out of a federation, as an example, that federation can still resolve a product. It's just never going to get that request from Apollo. The gateway just won't send it that data.
Got it.
So when it's on that, we go through behind the scenes and shift a bunch of stuff and make it all right and remove the code over here and make sure the federation over there works. And then once all that's done, we update our original schema to match what the old one is, and then we flip it back over. And it's really scary because you basically just say, hey, this federation over here that's untested, like this schema over here that's untested, it'll work, hopefully. And we test it, and by shoving it into prod, and it we
Throw it
normally
right
do
into
say
the fire.
Don't get that wrong. Yeah, we don't do it that bad, but it's like
Yeah,
we put in, we do our testing, and then hey, go to prod and watch our alarms and make sure nothing's on fire.
Yeah, for sure. That makes a lot of sense. So I want to get to this one question real quick. It might be more of a front end question. I don't know if you'll have the answer to it, but again, Tot RA or Tot Ra, let me know which one you prefer there. Asked, do you use one client on the front end, just like one Apollo client, or do you have kind of like front end microservices and maybe you're using multiple different clients?
I can't give you an answer on that one. I don't really know.
Yeah.
I think because we're moving towards micro front ends, but I don't know where they're going from there.
Yeah.
So we've had some interesting talks about that, of how can the graph handle that, and how can our graph stay up enough, and should that influence design decisions on the front end? So that's been an
Got it.
interesting one recently.
Okay, so just diving a bit more into that phrase that you just said, which is like, can our graph handle this? That's a very interesting subject to talk about, and I think it'd be really cool. Like, what are the numbers that we're talking here? What is the type of traffic that your GraphQL federated API is receiving? And yeah, what is some of the challenges maybe you faced being at scale? Like, once we figure out
Yeah.
what scale is for StockX.
Yeah, it's funny you mentioned that scale because it was great until we put like home screen on it and other painful queries that really hammer us.
Yeah,
But we sit anywhere from like 90 to 95 million requests a day. Um,
95 million a day.
yeah,
Okay.
we
Wow.
get we do a lot of stuff, and that's only going to go up from here, which is scary to think of.
Yeah.
But we also have a 3 nines of availability, so we're doing
Yep.
really well as well. So we're not, even though we do have a lot of requests, we're still doing really well. Like,
That's awesome. Yeah, it's great.
but yeah, the question, just to kind of give a little bit more background on that, the question is more, should I have this query that can load my whole page? Should I make that query at a higher level and then drop that data down into smaller components, or should I make a bunch of smaller requests? And we're trying to take a stance of that should be your decision, because we don't want the graph to influence how you make your code. Like, that just seems weird to, like, hey, the graph is your problem of making your code the way you want it, and then that can lead to maybe a great decision on iOS, but a horrible decision on web. So we're trying to
Yeah.
make it flexible so the clients can make that question and answer it themselves how they want, not necessarily us dictating that to them.
Yeah, yeah, that makes sense. So that is so interesting to me. So 95 million requests per day. And then we were actually talking about this. You also experience, there's times where you have like larger spikes in traffic, right?
Yeah. You're getting to the fun stuff of the presentation later, but yeah,
Ooh, yeah.
we'll
I love
see
it.
when we do push notifications. They do some crazy stuff. Like, at one point we hit almost 100,000 requests a second for a few seconds, and that
Oh,
was like a 10 to, like, what? That's like a 8 to 10x of our normal traffic.
a,
So we handle that stuff.
a
And again,
100,000 requests per second.
our marketing team does an awesome job. And when they shoot off a push notification, a lot of people hit that push notification.
And so that
Uh,
opens up the website or the app, right? Whichever, and then boom, 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 flooded.
yep,
So is this
yep,
like a hot item essentially becomes like you can start bidding on it, right? Or something, and
yep,
then the push notification goes out and people want to bid and it just
yep.
wow, that's
Or like,
very interesting.
yeah, that Nike will drop an item like, hey, a new Yeezy shoe came out. Come see what it is on StockX. Maybe you missed the drop from Yeezy, but you can get it
Yeah.
from us. Or, hey, like,
Uh,
maybe there's, like The Last Dance was a big one. When The Last Dance was going on, we'd say, hey, some of these shoes are on StockX. If you guys want to come, look at them.
that is wild.
And that stuff, hey, we'd send a push notification out. And again, shout out to the marketing team for doing an awesome job. But they'd shoot stuff off like that, and we have to be ready. And
Yeah.
again, you're coming to the presentation, but yeah, like,
Yeah.
it's that's what it is.
So another question from chat coming in: how do you trace the slowest resolvers in live? Like, what kind of like metrics are y'all tracking? Kind of stuff like that.
Yeah. A lot of it has to do with our metrics, at least, is average response time from a federation,
Hmm.
um, and then error rate from a federation. So, response rate, we have a nice APM monitoring a lot of stuff. So it just basically tells us, hey, your API call from your federation to this service does this, and it's
Got
roughly
it.
this time, and you know, we kind of do analytics from there. The other one's a little bit more interesting of, did you have an error? As we kind of all know, GraphQL doesn't give you your nice 500 error response,
No,
figure it
yeah,
out. So we actually wrote some cool custom stuff to go in and inspect our stuff that we return back and say, hey, is there errors in this? And if there is, update some increments and stuff like that,
yeah.
and tell us, hey, there's actually errors in these responses. And that's worked out really well for us. We recently made a change to do that at the gateway level and the federation level. So that's a nice, interesting thing too, is we now can kind of see like, hey, maybe this federation over here isn't doing as well as we thought, or say there's a payment one. It's like, people are putting in bad credit cards. That's, a
Right.
normal amount of errors. So.
Okay. Well, that's really cool. So, and then like this API that you have doing the monitoring, is it just like pushing data into like, somewhere like Datadog or like some other kind of platform or something? And
Yep,
y'all
it
are
just
building charts? Yeah.
all Datadog. We just use
Gotcha.
Datadog API on a lot of stuff.
Yeah.
And then we use that to create some custom metrics, all that fun jazz, and
Yep.
make fancy charts with fancy colors.
Fancy charts.
Yeah, I know, right?
Love it.
Like
That's
that's what it
awesome.
turns into.
Yeah, that's
And
what
then
it
you
turns
actually
into.
click the
Yeah.
button and it all disappears. So
Awesome, very cool. So I know that you had like a little bit of more information that you wanted to share. I'm thinking maybe this would be a good time to kind of dive into that little like presentation that you've thrown together. What do you think? Does this look like a good idea, or did you want to maybe talk about Barricade a little bit
uh,
first, or what's
we
the deal?
we can jump in and out of it as much as you want. If we start talking, people want to see our faces. We can hop out of it quick and all of that
Yeah,
fun
yeah,
stuff.
awesome.
I'm sure there's gonna be some talking points.
Okay, yeah, real quick. Rhonda388, thank you for the follow. And Kilonica, thank you for the follow a little bit ago. Much appreciated. All right, so I'm going to transition us over to your presentation, and then we can start to take a little look into what you got going on in here. And like you said, we'll jump in and out. People will be able to hear us too, so we can talk right through the presentation. So let's go ahead and do that.
Yeah, we can
Awesome.
use your $7 animations here.
I had to cut it for now. I got to lower the volume, so I just went with a little fade action. But I got some feedback. The volume was a bit high, so yeah. Uh,
Gotcha.
yeah. Young Suit wants to know what's the most amount of push-ups you've ever done.
Um, Unfortunately, I played
Uh,
baseball in college and I blew up my shoulder 3 times.
oh, so none. You don't do any now,
No,
huh? Yeah.
if I can get to 20, I'm happy right now. But
Heck
I
yeah.
still do it every
Yeah.
now and then. But
20 is a very strong number.
but
Yeah.
yeah, I just,
All right.
man, you ask me, I can do legs. I can do that.
There
But
you go. Yeah. That's so funny. Cool. All right, so I've got you flipped over. You've got control. So boom, here we go. We can just kind of dive. Oh God, look at how beautiful those airs are in the background. I
yeah,
love it.
man. Again, our teams do some awesome job and they do some awesome pictures.
Nice.
So again, we kind of skipped through some of this stuff and talked about it a little bit already, but
Yeah,
what is
yeah.
StockX? It's, here's a very good thing, a very good way of putting it. The one thing that we didn't really talk about though is we do authenticate our stuff. So the big thing that kind of separates us from a lot of other companies is if you buy that Yeezy, we make sure that you get that Yeezy and it's an actual Yeezy. It's not some,
Knockoff
really
or something.
fake or something.
Yeah.
Yeah. So, and they're almost, or no, they're not almost, they are guaranteed to be basically new. Somebody might have put them on, snapped a picture, and then taken them right off. But you're not
Gotcha.
going to get something that somebody's wore for, a long time. So that's a pretty awesome thing. And then again, we covered a little bit of this again, but like, how do we use GraphQL? We use it very
Ooh,
much
I
as
like this. There we go.
I mean, Google Drawings really helped out, man. You can just snap some stuff together. It looks real nice. But yeah, we basically have our Android, iOS web apps, and they send us information and requests, and we basically have an API gateway. We make sure, if you're authenticated, you're from us. Then you come to our GraphQL server, and we just stitch a bunch of stuff together. So whatever backend service, any of that stuff, we take it, we stitch it together, figure out your GraphQL response, and send it back.
So real quick, is it safe to say that like these, I see it's like a Kate's cluster. So some of these could be multiple. Are these all like individual services, and then that GraphQL symbol is the federated API gateway essentially, and then that's how it's talking to all those downstream services? Is that pretty close?
Yeah, it's pretty close. The one thing that's a little different on that is, yes, they're services, but we actually have a set of services behind those that are federated services, then talk to as REST APIs.
Got you. So this is layer. This is like, so we've got the GraphQL symbol is your federated API gateway. All these other boxes are other GraphQL APIs that are federated into that. That's awesome. And then behind those are your REST APIs.
Exactly.
Nice.
Exactly. Yeah, we
Cool.
like another layer of abstraction. We love it, right? As developers.
Yeah, yeah, abstractions on abstractions. Okay, real quick, question from the chat, which I feel like kind of fits in right here, actually. How do you validate that a federated schema is valid, right? I look at here and I see like, a bunch of different services. How do you make sure you don't have any like clashes? And like, how do you know that the schema is good to go? Is it just testing, like a staging environment, or what does that look like?
Yeah, we have a few things. So number one, Apollo check. It's surprisingly great at catching all of this stuff. If you mess it up, it will immediately tell you like, yo, this is not going to build. Like it just straight up won't work. So we have that in all of our CI stuff. You open a PR, it'll tell you immediately like, here's the first thing it runs. It'll work or it won't work. It's a great one. The other one is we actually run this in a monorepo, right? All of our services are in a monorepo.
Okay.
So you can start and run this locally, and it'll tell you, hey, I can't stitch all this stuff together, or I can stitch it all together. And you can test all of your requests out that you're going to run in prod as a front-end developer, or testing your back-end service right from your local machine to see if it's going to work.
And what does that look like? Is that like Docker Compose or something, and Docker containers? Because you're running Kate, so I imagine you're using containers. What does that story look like for the mono repo?
Yeah, we have packages that have their own individual node start commands, basically.
Oh, interesting. That's so easy. Oh, right. And then you just point it at the gateway at those URLs, and boom, there you are.
Hey, yeah.
Wow.
We use Lerna. You can use any monorepo. You can just say, hey, start a bunch of things up. If you really wanted to, you could write a script, but we've just found that Lerna makes it a little bit easier for us.
Yeah.
Go from there.
That is interesting. That's such an easy local development experience for such a complicated architecture.
Yep. And then we're getting even better at it slowly but surely. And shout out to Matt on my team. Sorry, all the shout outs to my team at this point.
Yeah, for sure. Of course.
He actually wrote a pretty cool script recently where we can actually start individual services. So if you don't need all of our federated services, you can only start the ones that you want. So you want gateway and so you can just say, hey, start just those two.
Yeah, like I just need products and gateway because I'm doing something specific to that. Love it. That's so cool.
Yeah. And again, it's all local. So if something's going right or wrong, Yeah.
Quick shout out, a techie thought. Thank you for the follow. It is much appreciated. Awesome. So I guess let's continue on with this. I'm loving it. Yeah, 90 million, mind-boggling numbers.
Yep. And I took that. Apparently, I must have taken like a bad week, or like the last week was really strong. I looked at it again, and it was 94 million today. So we're doing an insane amount of stuff. And again, 3 nines of availability within a year is crazy to think of. Like, still remember as of yesterday that our stuff was crashing, and I'm getting calls, and my my people on my team are getting calls, my leaders getting calls. And now we're sitting back, sitting pretty.
I have a fun story about that. When I was at Major League Soccer, we had introduced GraphQL. Everything was looking great. We had done some good load testing, but clearly not enough. And on one of our, we have 3 really heavy traffic days a year, and on one of those really heavy traffic days, everything went down. The GraphQL server just like crashed and burned. I learned a lot that day about working full of anxiety and under immense amounts of pressure.
You mentioned that. I've done a Federation shuffle where I screwed up the URL, and every request that was going to go get a product just, and it's just like, oh no. What about this?
So rough. Yeah. Cool. Awesome. Sorry, I didn't mean to derail you. Please continue on. I love sharing my stories of destruction and failure, just because I feel like other folks out there, it's good to hear other people mess up too.
You're gonna love the second half of this presentation.
Oh yes, I can't wait. Yeah. Let me get to it, please.
So again, pre-warming for Barricade, man, it's perfect.
I love it. Yeah.
But so one of the things we did. Switching gears back to how do we use GraphQL?
Yeah.
Again, we use it a lot for stitching data together. So instead of having our microservices go and have a microservice between microservices to stitch together their stuff to make it then usable by a front end, we just made GraphQL do all of that.
Yep.
We have a federated service. It works with your service. It then comes up, goes to the gateway, and gives your gateway, or gives the ability for your data to be exposed publicly, and to all of our apps. We use it for caching. Awesome. You have one place where all the traffic's coming through. Great place for all your caching to do. Hey, we can just not do as much stuff to you guys. And we use it as an acceleration layer on that too. Like, again, if you're all coming through us, if you make a request, Kurt, to get a product, why can't I use that cached value? And how can we share that across all the federations? So if somebody loads a home screen and they get a product, when you load a product page, that should just be the same call. You don't need to have everyone. And it's, again, acceleration just through doing good caching. So that's been awesome.
Cool.
And then there's been a lot of positive benefits to using the graph that don't really get talked about in a lot of places, but are pretty awesome. So error handling, right? Like before, a lot of the stuff at least we had was old, and it's getting a lot better. Part of that though is error handling. If a request fails, your page fails. That's not a good experience. You hit a product show up. Like that's a horrible experience. So can you progressively load that, or even then like, hey, we got this part of the stuff back, and then the other stuff just didn't work, but you still get what you can see, right? Like it's perfect, right? Like, do you really care if like the image, say the title doesn't load? Is that really the end of the world versus like seeing everything else on the page?
Some is better than none, I always like to say.
Yeah, and especially if you're like throwing a 500 error and just like, hey, the page crashes. It's like, oh man, that's even worse.
Yeah.
So that's an awesome one. We took a huge inspiration from protocol buffers in gRPC. Almost everything in our graph is nullable. There is almost nothing that is required and nothing guaranteed to be returned.
Yeah.
And that is a very interesting statement to a lot of people, because it's like, what do you mean you can't guarantee that I'm going to get an ID back, or you're not going to guarantee that I have to send you an ID? Everything's required until it's not. Like, say today we require you to pass an ID, but then we run out of integers, and tomorrow we have to take a string. All of a sudden, you have to pass in 0 because that's the way it used to be. Like, or hey, a front end is expecting an ID to come back. What happens when you don't get one back? Do you just crash your page and crash your app?
Yeah.
Like, we force you to kind of think of those things, and it's been hugely successful. Like, it's a little bit to write that code, but like, the benefit is awesome.
Hey, Chris Damaris has entered the chat.
Oh no! Man, Mark, good to see you, man.
Real quick, we got a question, 2 questions coming in. So first one is, do you have max execution time of resolvers? And I guess meaning like, do you track the max execution time of resolvers? I guess would be the question there. And then second is, do you have a common naming convention? Like, how do you handle naming and all that, that many unique types and all that fun jazz?
Yeah, so we don't really have a maximum connection time or execution time. We do track how long it takes a federation to respond. So you send it, like the gateway will split its request doing its query planning, send basically the request to them, and then the request happens in the federation and returns back. We track that time.
Yeah.
We don't track resolver to resolver.
Gotcha.
With the sheer amount of resolvers we have, that just might end up being like too much data to like really be useful. And it might just slow everything down just for the sheer fact of like, start a timer, end a timer, send it to, metrics place, and do that on, thousands and thousands and thousands of requests a second. Like, it's just a lot.
Yeah, that makes sense.
The other thing that happens that we found out when we did this for some other stuff is if you do that, you can actually overload your metrics place. So like we use Datadog, we actually almost took down our Datadog cluster because we put too much metrics in Datadog.
Yeah.
And it had to scale, and it did eventually, but like we were actually getting problems because we were just sending it way too much.
Yeah.
So be cautious of what you ask for.
For sure. Then you got to do averages of averages, like only sending an average amount of requests, and then that's like a whole thing in and of itself. And it's like, and real quick, apparently you used to have a beard and you no longer do. What happened? What's the story?
it was getting thick, and Demars knows this. I do this every time. It gets thick. It's the summer. You cut it off. You get like 3 days in the office where nobody recognizes you. You can do work, and then they realize
your disguise.
And you get questioned again. So it's all smoke screen. It'll come back. Trust me, Demars. It'll come back.
That's hilarious. I haven't got the full story of how you know each other. I think y'all used to work together. Is this correct?
Yeah,
Yeah.
he was the guy who actually. There's the question too.
Yeah.
Um,
That's why I
he,
asked.
me, me and him worked at United Shore together.
Okay.
It was my first dev job. I was still in college. He would tell me things every day, like you need to learn this, you need to learn this. One of them was actually GraphQL, and when I saw, it, I was like, this is actually an awesome technology. We should
Yeah.
use it. I pitched it at the company. I promptly got told no. I took it to the next company, pitched it. They said yes. So hence we're here.
Awesome. Love
He's a
it.
good dude.
Cool. Real quick, one more question, then we'll dive back into the presentation, which is, do y'all use persistent queries or um, just standard queries? Persistent queries is like where you basically
Yeah,
boil your query. You know what it is, so then I'll just let you
yeah.
answer.
We don't. Um, we just have them come through. Again, this kind of goes back to like, can you stay up? Like, if
Yeah.
we have to do persistent queries, it just might not work out well. Like,
Yeah.
there might be with how liquid our environment is of like, hey,
Liquid.
somebody might have bid on your stuff. You don't want to see that like somebody you get an email saying somebody bought something or bought your item, and then
Yeah.
you go on and hey, it's not sold yet. It's like we can't really do like there's limits to what we can do with that, so we can't really turn it all on because it would do weird things to our stuff.
For sure. For sure. Yeah, that makes a lot of sense. All right, so let's keep this train moving here because there's so much good information. I'm learning so much. So I'm gonna flip this back over and let's talk a little bit more. So I think we left off on like we talked a little bit about everything potentially being null, which is cool because it forces you to kind of handle all of your use cases on the client and make sure that that is solid and that you're not going to catch any unexpected issues. So that's pretty interesting. And then yeah, I'll let you take it from there.
Yeah. The cool thing to just the last note on that one is it also leads to what we talked a little bit about like can you partially load a screen? It kind of forces you to think of like what is the data I need to load it, and then like what's the stuff I can just kind of like let go if I don't get it,
Yeah.
which has been huge too. Of like you might just not get some data, but your screen loads,
Yeah.
which is awesome.
Yeah.
Less back pressure on backend services is the next one. Awesome idea if you guys think caching right. How can we enforce caching to make our servers on the back end handle less, or not handle less, but need to handle less? So instead of them taking the entire brunt of everything that happens, how can we make it so they're only getting 1/10 of the requests we're getting? And can we make that so potentially there's services that we can run less pods, be a little bit more cost efficient, and still get the same performance to front ends,
Yeah.
which is surprisingly nice. Like again, like we saw like a nice just dip and stuff once we start add caching, and we can control that and just kind of watch the side effects on the back ends of like, hey, we can cut our pods in half or something like that now because we're just not getting a lot of requests. It's like
Yeah.
perfect.
That's cool.
Way easier to maintain is the next one. Way easier to maintain. Like I mentioned at the start, it kind of grew out of like, hey, we need to do the same change in like 7 different spots and 7 different things, and they all need to work the same. They all need to work the same. What sucks about that is you have to do it in 7 spots. You
Yeah.
do it in GraphQL. You update the one node. You make your
Done.
changes there. You update your one federation. Hands off. Everybody gets the update. Even if you're on an old client, you get the update. And it's just
Love it.
so much easier to just kind of take your hands off and say, here's my new value and be good.
That's a really good point that you just raised on the last one is that if everything is using GraphQL, even older clients, less used clients that aren't a high priority, right, on the work list, they're going to reap the benefits of it as well because nothing needs to really change on the client. The query face looks the same regardless of what's happening behind the scenes. So that's really interesting. That's something that I hadn't really considered and another really good use case.
Yeah, again, the whole point of this positive side effects people don't find all the time, right?
Yeah, yeah, absolutely.
If you can do that, like it just allows you to keep those apps kind of out in the wild, but not gonna like you're not gonna freak out if you get an old version of your app out there,
Yeah,
right? Like if you have an old version, it's like, is it still running the same queries? Yeah, I mean maybe they're just missing a field here and there, but you're still getting the correct data back, which is huge.
yeah, absolutely. That's awesome.
And the last one, this one's kind of weird, but query ergonomics. So before with all these APIs, right, in REST APIs, if you're perfectly REST, you might know everything that's going on.
Yeah,
But there always turns into that question mark, like this query param, and let me add this query param, and let me add this thing over here. And then that leads into like, hey, we're gonna add this little data, or like you can't remove this, but it doesn't do anything. If you can write your schema in a really nice way that allows your front end to kind of intuitively know what's going on, the ergonomics of that are so simple. Like we were talking in Slack before this today about a shipment. It's like, okay, well, under shipment, we want to add this field called deploy or delivery. Well, do you call it shipment delivery? It's like, well, that seems kind of weird if you're writing code to go like shipment delivery like delivery, like those renaming of things just seem really weird at that point.
Yeah.
If you can get it to like shipment delivery whatever, right? Like that's so much more intuitive than a lot of other things.
Absolutely.
And the ability to spin up front end devs from that is you no longer have to be like, here's my 700 Swagger docs to figure out.
Yeah.
It's here's your query. The query does this, and this is what you think it is, and here's your other thing. It's exactly what you think it is, and you just kind of like, if you can make it nice and it's not some weird path, there's something to be said for that from the front end teams that we've talked to of like, this is nice.
Yeah, another thing on top of that is you can use, like if you're using something like VS Code, the GraphQL or the Apollo extension, and get IntelliSense. So as you're writing the query, you can actually, it could be predictable. If you're not that far, you can spin up graphical, check out your query, copy it out, paste it into the app, and you're done. It's more exploratory and easier to just find what you need, I often find.
Yeah, it's really nice, right? Like, so that jump is really nice.
Yeah. Real quick, before we move on to federations, we got another cache question. So since we were on that topic, I just want to kind of hit that real quick. Hang on, they're coming in hot now. So do you ever have to break cache? Like, well, how do you handle your cache? Is it just like a TOS or TTL type thing? Or do you have like specific ways of breaking it based off mutations and stuff like that? I guess kind of like, how do you handle caching? You don't have to go too deep into the nuts and bolts of it.
Yeah, so far for what we have in our graph, we haven't really had any problems of what, like, we need to break the cache, right? Like there hasn't been anything that's that pressing to where we've cached it and they need to break that cache for whatever reason. And it kind of goes back to like, if you're looking at a product and the product title changes from like, title A to title B, are you really that angry if it's a minute out of date? Or I think like 2 seconds out of date, right? Like, if it's
whatever it is. Yeah.
By the time you pull out your phone and tweet at us that something's wrong, that it's fixed, are you really like, do you need it that bad? And that's kind of where all of our data in the graph is that's where it's at right now, is just, we don't have anything that sensitive that we're caching, that we're doing that way. We also have kind of nice selective caching that we apply. So it's not like blanket caching on everything.
Right.
You actually have to do it per resolver and per API call to be like, this is a cached thing.
Got it. Yeah, which makes a ton of sense. And like, that's kind of how I've seen it handled a lot of times too, is you just set like, you decide on what that cache timing needs, what's the acceptable time for something to be, air quote, because y'all can't see me, stale, and then, clear it out, And that's it. And then, so last question real quick on this is, do you maintain the REST APIs in parallel? And how do you sell maintenance if two APIs for other teams? I don't think you sell anything, right? Like these are just internal APIs?
So our very high level overview is all the backends are REST, and then we only expose it through GraphQL. So we don't maintain the REST ones, they're backend, right? Like the backend is the person who's maintaining that REST endpoint that then gets integrated with the graph. So if another backend service needs to talk to it, it's not trying to do some weird network loops where it like might go out to the public internet and then come all the way back in through GraphQL and then finally make it over to the service literally like to the left of it. Like, they talk through REST APIs on the back end, and then to expose it, you integrate with the graph to expose your data.
Yeah, I think maybe this is what Todd was trying to say. Correct me if I'm wrong too, but like, you're in the middle of migrating, so you're still having to use REST, but you're also using GraphQL. But at that point, it's not maintenance of two APIs, because once you adopt the GraphQL part, you're no longer using the REST part of that API. So if you're still using REST in another part, you're going to have the same concerns you had before you decided to adopt GraphQL. So I don't really feel like that makes it. Okay, so no public REST. That is what he was asking. Yeah. Okay. There we go. Yeah. All right. Let's keep this train rolling. I'm loving this. It's so much good stuff.
Cool. So by the time I made these slides,
Holy
it said
crap.
14. We're actually up to 18 right now. With our shuffling of stuff around, we've created a few more. We're now up to that. Our federated services will handle anything. Some of them handle close to 7,000 a day. Some are up to almost 10 million a day. So huge difference on what each thing handles. We proxy 8 internal services and 5 external services. So one thing we've done that's kind of cool is if you want to use an external service, we can proxy that through the graph as well, giving a nice interface. So you're not locked in with your vendors, which has been pretty awesome to see, to be honest.
Yeah.
And I actually looked up the number today because I was curious. We have one service that actually has a 1,000 requests a second. So that was a pretty cool number to see today as well.
That is a very cool number to see. That's a very high. 1,000 requests per second means 1 per millisecond. That's wild.
99% up, or 99.9% uptime on average too.
999. Love it. That's good stuff.
So it's pretty cool. And now to go in the fun thing we've kind of teased.
Ooh, yeah, Barricade. Yeah, I can't wait to talk about this. So yeah. No, I was gonna say, why don't you let us know like what Barricade is a little bit, so like maybe these metrics that everyone's seeing might make like a little more sense. I just love like the quick 1, 2, 3 on what is Barricade and what is the problem it solves.
We'll get to that. Let's frame the problem first, because
Sure.
the problem's actually an interesting problem.
Yeah, let's do it.
So these graphs we took from our stuff when we were having basically push notifications. So you said, we mentioned it before, we see these massive spikes, right?
Yeah.
So this is where it goes from about like 12, 13K requests a minute to 80,000 in like less than immediate snap fingers, where we had these massive sets of requests. And you can see from the bottom, that's our error percentage. We're not doing too well. We're doing bad. It's just not doing well. Like it was bad for a while, right? But again, like our marketing team,
I'm just picturing you all at your desks.
We're just sitting there. All of our phones are going off. We're like, we know it's a problem. We're waiting for auto scaling to kick in. We're waiting. Like we know it. And as you can see, as it goes on, right? Like the last one that happens, we're fine, right? Like auto scaling's kicked in. We're completely okay at that point. But getting to that point, we had some problems.
For sure.
Right? And again, shout out to our marketing team for doing a great job in getting that spike. When we send out a push notification, people hit the push.
Yeah, that's what you want.
Yeah, it's perfect. So we run in Kubernetes. We kind of had that cluster picture in there earlier. We have what's called an HPA, horizontal pod autoscaler.
Yeah.
So all that means, you set some limits. If you exceed those limits, the HPA will kick up a bunch more pods for you.
Yep.
And this is kind of the graph of what happened before, right? So you can see these spikes of these really sharp increases, and then it kind of tapers off. That was a push happening, and us freaking out, scaling a bunch of times, and then it would kind of die down in traffic. And then another one would hit, we'd see another spike up, and it would just kind of keep doing that, right? And what would be nice is like, why don't we just scale it before this push happens, right? Like, why do we have to wait until the push if we know it's coming, right?
Yeah.
Like marketing can tell us like, hey, there's something coming, like be ready. So that's honestly kind of what Barricade did. Like we tell Barricade like, yo, there's gonna be a push coming. Scale a bunch of pods up and be ready for this. And you can see we did this, there's a box there. We scaled up before the push happened. We still scaled up a little bit, but you'll see in the next slide, there's not a ton of problems that end up coming up with that. And
so in this instance, is the yellow, what is the yellow and the purple? Walk me through that. Like what am I looking at here?
So these are our number of pods.
Okay.
The number of pods that we have
crap.
are able to serve traffic, right? So we pre-scaled them and said, hey, go to this high number, right? And that's kind of what Barricade does. It takes you schedule an event, you say, hey, something's going to happen. Scale this service.
Yeah.
And it scale that service.
These are all different services.
Yep.
Okay, I'm with you now. Holy bejesus. And then you're scaling from around 90 pods up to 260 pods. Is that what I'm seeing?
Hey, the HPA kicked in at the end and got us up to the 360. But
Yo.
Yes. But that's what we needed to handle traffic.
Yeah.
Like,
yeah.
We didn't scale up that high, but we scaled up high enough so it wasn't a crash at the start.
For sure.
And then it took it from there.
Yeah, because
And
it's cascading. If you crash from the start, any pod you start up is going to catch all the incoming requests and just crash and crash and crash. Oh, I've been there. Oh,
yep,
it's devastating to
yep.
watch happen.
Um,
Yeah.
and again, and the cool thing with federated services, right, is we can scale independently. So what you see on this is that top line really scales, right? Like we're getting that, we know that service is going to get hammered. So we really scale that one. But the stuff at the bottom stays constant. Like that's
Yeah,
stuff that like that part of the graph we know isn't going to get hit by push notification.
for sure.
So we don't scale that part. And that's kind of the cool thing of Barricade is, and with federations mixing that together is, if you know where your push notification is going to be, you can actually scale just those parts of your graph and nothing else. So we
Yeah.
don't have to have all of these pods just sitting there at like, 0.2% CPU because nobody's sending enough requests.
Yeah.
We can scale just the stuff for the push notification, and that's the only thing that happens.
So just real quick, I just want to take a second to focus on, which is like this is like an architectural thing, and one of a major benefit of federation and having your GraphQL APIs broken out, right? Because in a monolithic API world, you actually can't really do that. Like you're just forced to scale everything, which is no different than having microservices and REST versus one REST API that does all of it. But we tend to see a lot in GraphQL world the idea of one graph. Oftentimes, even if it's talking maybe to multiple REST services, could in itself be a point. Even if you have just one graph, then you're still kind of stuck in that situation. You've now created a bottleneck. You could have 50 million underlying REST APIs, but until you break apart the graph, you could end up in a pretty interesting situation. So I just wanted to touch on that as a quick note. Yeah.
Welcome to our pain.
Yeah.
Again, that's our pain. Like literally, we would get those pushes, and we can scale our backend, but it doesn't do much for us. And you've seen the pictures before. We didn't do well until our stuff started scaling.
Yeah. So now we're looking at Post-Barricade, right?
And this is just again insane to see. We did a test run to see what it was. Like, is this idea worth continuing or not? And you can see like we went from, at some points we hit like 93% error rates. Like you would send a query and literally one person out of 20 would get a valid response. Everybody else would get an error. Now after this, it's literally under 1% almost every time. It's
everybody's
rare that we
singing.
Yeah, it's rare that we see any dent in anything.
That's like, amazing. Yeah.
It just like, it was one of those things where you see the graph and you're like, there's no way this is right. There's just like, no way.
You start to question it. You're like, we got to break it again to make sure that this is accurate. Yeah.
But yeah, so that's kind of what Barricade did for us. It's been awesome to see. We're working on stuff for this. We would love to say we have time to put it out as open source. We're slowly working towards that. It's an internal goal for my team and a few people that worked on this.
Nice.
So hopefully eventually we can show this to the world and share it with people.
Yeah.
But as of right now, it's just this video and people go from there.
Do you mind if I ask a little bit more about how it works? Like, what's the process for marketing to let you know, and then how to like adjust pods, right? Like, is this configuration file or something, or like an API call? Like, how does that work? A Slack command?
Oh, you're gonna love this because it's so dumb and easy, but it works really well. But it actually, under the hood, all it is a scheduled kubectl command.
Oh, that's so smart. Yeah, that makes sense.
You schedule an event. You say like, hey, it's going to start at this time, it's going to end at this time, and this is the service I want you to warm up. And then from there, it basically just has an internal clock that keeps running and says, hey, like
it's time.
It's that time.
Here's an event.
Run the CTL command, and all of a sudden it works. Like, and then it just keeps listening and like, hey, the time passed. It should cool off now. Cool it off, and you're back to normal. That's kind of it, really. Like, it's not fancy. The only thing that's kind of cool is if you give it a random service, right, and it hasn't, the one thing that it does have to have is it has to have an HPA hooked up to it because it just plays with those values. But you can, if you don't give it a custom config to say, hey, this is what I want your new minimum and maximum in your HPA to be, it'll just take whatever is there and just double it. Just naively, hey, just ×2, figure it out, and go from there. And that's it, right? Like, unless you need something custom, you can change it from there.
That is the coolest thing ever. Yeah, which makes perfect sense. And honestly, I'm a fan of like keep it simple. You know, keep it simple. It's easy to make things more complex. It's a lot harder to make them less complex. That's my motto.
It's just funny to see because we were all like, "There's no way this is gonna work this way. There's no way this works." And then
Sure enough.
now we're
Yeah, and you're right because you know they're coming. You know, it's like it's like a marketing event, right? Like it's not known, so only
yeah.
makes sense to prepare for it. That's cool.
Yeah, and we just have a thing that listens for marketing to schedule their stuff in their CMS, and we just pull that in and schedule an event and move on from there.
Yeah. So we got two questions out of the chat. I'm gonna hit you with the first one, which is, what is the backend tech stack? Is it Node.js only, or are y'all using different languages further back? What's the story there?
We do some Node, we do some Go, we do some. I think we have some Ruby services. I know we have some PHP services. It's a little bit of everything. We're trying to standardize, but as everybody knows, you don't like. It never works out. You end up picking the best tool for the job and going from there.
That's how it should be. That's what I feel. Polyglot for the win, right?
Hey, if it works, it works, right?
Yeah. If it ain't broke, don't fix it. Cool. And then the second question is, do you have any kind of like query cost evaluation going to avoid abuse or recursion? I would imagine it's an internal API, so there's not a lot of malicious intent coming. So I'm curious. Yeah, do y'all deal with any of that? Like, do you have any like rules in place to prevent deeply nested queries, stuff like that? Cyclical references?
Yeah, no, we have a few cycles you can make in our graph. We just, like you kind of said, it's all internal right now, so we haven't really spent a ton of time like figuring that out yet. Yeah. We've had some internal discussions about it, but we haven't made a big decision yet, but we need to, and we've all noted that we need to.
Yeah, so it's in the works, it's just not there yet. Cool.
Yeah.
Nice. Awesome. And then, let me get back to this last one because this is important. Let me flip over there. Boom. Look at that. Yeah. So they're hiring. Heck yeah, that's cool. Well, let me drop this link in the chat too so that people can get right to it. StockX.com/jobbyjobs. Not really, it's just /jobs. Don't go to /jobbyjobs.
Don't do that. Don't let me see that like API miscall and then I have to see and go from there. But yeah. Awesome. We're hiring. If you guys think that any of this stuff is interesting, feel free to stop by our jobs page and come, throw in an app, come work with us. It's some interesting stuff. It's a pretty awesome company. So
it's cool. It sounds. Someone dropped the link in Jobby Jobs, but they didn't make it an actual link. But thank you. That sounds like a really cool place to work. Not gonna lie, that's awesome. So yeah. Thank you so much for coming on. I would say we'll leave a couple minutes. Folks, if you're in the chat, you got questions. Let's keep it going. Was there anything that we didn't get to cover that you're interested in covering or want to talk about?
I think there was one that we mentioned and then we never got back to.
Oh, let me check that out.
Naming. It was something on
naming. Do we have common naming. Yeah. Good call.
Yeah, so we've standardized on a few things. A lot of it is just if you Google GraphQL and like look for standards, we've kind of adopted a lot of that stuff. This is all of our first times at StockX making a full-fledged public API, or not public API, but an API using GraphQL. So we were like, hey, let's look around and find a lot of things.
Yeah.
So we have that. A lot of it is, again, like if you're doing an input into a mutation, you name it with input to make sure it's not misconstrued with something else. We had some specs come out internally about filtering and how we want to do that to be consistent across the board. So
cool.
If you filter for one thing, it looks very similar to filter for another thing. If you put all in front of a list, that means you're not going to get a paginated list. Kind of just interesting things like that. We take the connection pattern from Relay. That's another one we do. But yeah, it's a lot of like, if you just look around, there's a ton of stuff out there, and we've found that it works really, really well.
Nice. Speaking of looking around, you can also drop in the GraphQL community Discord. There's a lot of folks in there having conversations about federation, API management, and stuff like that. So let me see if I can get that link here. Let's see if this bot I did works. Oh, it
Ooh.
worked. Cool. Look at that. Pretty neat. I've been adding a Twitch bot to the stream. Yeah, so yeah, that's a open GraphQL kind of community thing, and yeah, it was a real big hit for GraphQL Summit, and we said, we don't want to just close that off, so we're gonna, we turned it into GraphQL Community Discord, and we want everyone to be able to come in there and talk about the GQL. You know what I'm saying?
Mhm. So
Uh,
let's see.
How does that play with federation? A little more clarification. You mean like the
I,
filtering stuff?
I think he's talking about relay because his message before was like, do we use?
Oh, yeah. There you go. Good call.
Um, I don't I don't know if we use relay to be honest with you. I think it would play fine though, because if you look at the way a gateway behaves, it behaves just the same as a normal GraphQL server. So I would imagine it would work perfecally fine,
Yeah.
to be honest.
It's
The only thing that might
passing the
differ,
query, so it doesn't matter as long as like the underlying schema is capable of handling it. It's gonna work just fine.
the only thing that might be a little weird is like it doesn't handle subscriptions yet.
Yes.
If you're using Apollo, so just don't use a subscription is the best thing I could tell you.
Yeah.
It, that's about it though. I mean, like you said,
Yeah.
it's the same thing.
What I have seen folks doing is if you do need subscriptions, they have a dedicated GraphQL API that handles subscriptions only. And because you are using links, if you're using Apollo Client, it's a separate link for your subscriptions. So you just specify the different URL for that. You still get the benefits of federating your GraphQL API. You could still use subscriptions, but instead of having just your gateway, you have your gateway in a subscription manager. Boom, boom, bam.
Fancy.
Fancy schmancy. That's what we like to do. Yeah. But yeah, yeah. Let's see. So we'll give a second for any other questions to filter into the chat. While we wait on that, just a couple of updates. Tomorrow I'll be streaming with Trevor Blades, and we're going to continue working on a collaborative soundboard app that was named by the chat Jam Spam. So we're going to actually add commands so that you can, from the chat, spam us with sounds while we're streaming. Should be a lot of fun. Yeah, but I'm trying to think. Other than that, we got Orbit coming up next week. We also have next week GraphQL and Vue. So if you're interested in learning about Vue and GraphQL, definitely tune in for that. You got anything else you want to throw out there before we get going? Before we wrap this up?
I think that's about it. Yeah, I don't really got anything else.
Awesome. Well, with that, thank you so much for coming on the stream, Kyle. This was amazing. You shared a lot of awesome information about what StockX is doing. I'm sure this is useful to a lot of folks. This video will be available on Twitch for a while, and it will be uploaded to YouTube. I'll be sure to let you all know. You can follow Kyle at not Kyle Schrade.
Yep.
Yeah, not Kyle Schrade, and you can follow me at Kurt Kemple. I'm sure we'll both be tweeting about it once it hits YouTube. Yeah, we appreciate you all. Can't thank you enough for joining us. And with that, I guess we can go ahead and say goodbye. See you later,
Thank you for
everyone. Yeah, loved having you. See you, everybody.